So today we're going to look at a way that you can use VBA to overcome the issue in Excel of the if statements only accepting maximum of 7 inputs. So the example we'll use is sizing pipes. As we can see, I've set up a spreadsheet here with the pipe sizes in green as well as the input and output. So the nominal bore of the pipe size is here on the left, with the corresponding maximum flow rate on the right. So we use the maximum flow rate to size the pipe. For example, a 20 ml pipe we can see only allows a 0.16 litre per second flow rate. Now this is based on a 500 Pascal per metre pressure drop or a maximum velocity of 2.5 metres per second. So that would want to be a 25 ml pipe. So if we put 0.2 in the input, we would expect that the pipe size at the output would be 25 millimeters. So to open up Visual Basic Editor, we need to have the Developer tab, and you can click Visual Basic. If you don't have the Developer tab, click Options, click on the Customize ribbon, and on the right here you can see the Developer checkbox. So check that box. Otherwise you can press Alt 11 and that will open Visual Basic Editor. So here's the editor. The first thing we're going to do is insert a module, and I like to label my modules when it starts to get more complicated and more subs and functions, so I will label MDL functions. Good programming practice is to always have option explicit, which means you have to dimension all of the variables, which means that Excel won't get confused between different variables and it knows exactly what they are. So the first step is we're going to use a function. So we write public function, and I'm going to call this function pipe size. We press enter, we can see that we have two brackets which have appeared, and that's where the input arguments need to go. So the inputs that we need for this particular function is the flow rate, so I'm dimensioning that as a single, as well as the pipe size range, which is where we get the size and maximum flow rate information from, which is the green box on the spreadsheet. And as the number will be a whole number, I'm dimensioning the result of pipe size as an integer. So here we go, that will be our range pipe sizes, and we can see that I've already labelled this, given the range and name pipe sizes in Excel, and I've put the input, named that as flow rate. So now we are going to use a for loop which requires a counter I, which will be an integer, and we'll say for I equals 1 to range pipe sizes dot rows dot count, which will give the range pipe sizes dot row dot count will count all of the rows in that range. So because we don't have any extra data, we want it to only loop through as many rows as there are in that range. So just to check for those who aren't familiar, if we use the immediate and change the range pipe sizes, because Excel doesn't know what that is yet, and we just use a spreadsheet reference range pipe sizes and press enter, it gives 14 rows, which is the number of rows in that range. So if we clear the initial inputs and we look at our initial thing we want to test, which is that a 0.2 flow rate will give a pipe size of 25 millimeters. So back to the function. If we write an if statement, if range pipe sizes I, which is the row, 2, which is the column where the maximum flow rates are, which is what we're comparing our input flow rate to, is greater than SNG flow rate, then, and I always close the ifs immediately so that it doesn't get confusing, pipe size, so the function result, will equal range pipe size I for the row, and this time the result column is 1. And once the function is found, the result, we want to exit the for loop. So compile error, quick check, forgot an S, compile. So there's our little function. So now we're going to type this in on Excel, and we can see that the pipe size function has appeared, and we put our flow rate input and our range input, and we close the brackets, press enter. We see that we get a value of 20. That is because the input flow rate is 0. So if we change that to 0.2, we get our pipe size of 25, which is what we expected. We test this with a few other values. Let's look at the 90 ml pipe, which accepts 13 litres per second. 12.8 doesn't exceed 13, so 90 is the correct size, whereas a value of 13.1 requires the pipe size to be increased to 100. So thanks for watching. Just another couple of notes. I'm going to post a spreadsheet link for those that want to look at it. And I used the .rows.count method because when you have dynamic tables which are constantly changing, the row number changes, it's just easier. Otherwise you could just use 14, that's no problem.